All right. So, hello everybody. Welcome to the show. I'm looking at my microphone levels. This is looking good. Looking at the stream, I can see myself. And I am hopefully muted. No, I am. Okay. All right. Cool. So for today, firstly, if you remember, last week I said this week there is not going to be a live stream because I'll be in London to record a video. It turned out that we had to make a couple of changes. I'll still be in London, but I'll fly out early tomorrow morning. So this is the last thing that I do today before I really get a good night's sleep, because it's going to be a really early flight. But the good news for you is we're going to do the live stream, and we're going to look into using Codable to call Genkit, and this is a sneak preview. We're going to look at what is new in Genkit 1.0, or respectively, what do we need to do in order to upgrade our code to Genkit. And it's not very much. That much I can tell you in terms of what we need to upgrade. But Genkit 1.0 has a nice, beautiful, updated UI. It looks very fresh, very clean and beautiful. So it's pretty cool. But this is a sneak preview. Audio is good. Awesome. Thanks so much. All right, so let's get into the code. So hopefully the chat will stick on. Perfect. Awesome. I love it when things work out. Oh, and also, obviously, I didn't type the greeting to Noe, so that was my cloud bot. So this is working as well. Amazing. So we are in our Firebase console here. So I already prepared stuff a little bit. So I fired up my my Firebase emulator. I've also got the compiler running in the background, so that if I make any changes to any Genkit code, it should pick this up. We've got the emulator booted up, and it has loaded the data that we stored last time. Remember that I told you how to do that. So you can use a special command line parameter on the emulator to tell it to persist and reload everything or all the data that you store inside the emulator. And that applies to both Firestore and the authentication. One thing to keep in mind, and I ran into this again while preparing, so I was playing around and was trying to make a call from my application to the backend, and it said, sorry, it does not work. And I was like, what is going on? Because there are always so many things that can go wrong. And then I remembered, oh yes, of course, the user that we have in our database here, that probably has a different authentication token than the one that is persisted in our application, or the token has expired. But anyways, you need to sign out of the application and sign in again. Noe, I know that you're on the stream because I can see that you're typing. Here is a question for you, and maybe you can look this up while I'm working on the other stuff. So I think, or I'm not entirely sure, if the fact that when I boot the emulator up again and it's reading the authentication data from disk, and I'm also booting up my application, and the application is reading the authentication token from the keychain, technically this should work, right? But why is it not working? Is it because the token has expired and I need to add something to keep refreshing the token. It might be because there is another callback that we haven't implemented. So, you know, maybe that's your challenge while you're watching. So sorry for making you work while you're on the stream. And to answer your question, I can probably find the token. And to answer your other question, so the cloud bot is not something that I wrote. It is something that is provided by Streamlabs. Cool. So let's look at our code. Let me get my IDE. Okay, here we are. And let's also make sure that you can see this. I mean, it's not important to see the navigator. Okay, so the thing that we did last time that resulted in a slightly inconvenient piece of code is that when I typed this piece of code here, I was too lazy and I made too much use of Xcode predictive code completion. And while this looks good and it does work, you might remember that when I made the call to my Genkit flow, the data that we were passing was not in the layout that the flow was expecting. And that is because originally when I was preparing, I had been using Codable. And here, as you can see, we're not using Codable. So maybe for those on the stream who are not, you know, iOS developers or who need a refresher, let's look at what the Swift Codable protocol is. So Codable is a type that can convert itself into and out of an external representation. That sounds very ominous. Let's try to parse this one piece at a time. So a type, that means any piece of data, essentially. So it can be a struct. So a struct, for example, that can convert itself into an external representation. So an external representation might be a text file. It might be JSON. It might even be XML. And then it can also convert itself out of an external representation. So that means if a type conforms to Codable, that type can somehow magically turn itself from a memory representation into an external representation, which might be a JSON file. And we can also take that JSON file and turn it back into a Codable type. And I said file, but that's not entirely correct because JSON objects can either be persisted on disk, and so they're a file, or they can be in a database, for example, in a Firestore document, or they can be a memory representation. And then it goes on, you know, and this is the thing about Apple's documentation. A lot of the documentation really doesn't go into how you really do this. So maybe this part here that talks a little bit more about how you do that. And here we have an example. So here we have a struct, a landmark that has a name and a founding year. And then down here, we conform it to Codable, and there is no other change. And then let's see if they show how you can fetch and persists. No, they're not showing this. Okay. Let's see. Flight school Codable. I think Matt wrote about it. Yep, there you go. So this here is a wonderful book that I can warmly recommend if you want to know anything about Codable. And by now it's free. It used to be a paid book, and it was worth every single penny. And look at the amazing artwork that Matt created for it. I think he had an artist do that, but it's just looking amazing. So let's see if we can get this and take a look. Hello. Here we go. All right. Okay, so, and the entire book is written with the idea of you're learning to fly. So it's very, very cute in a good way. So let's look at what we need. Yeah, and you know, it's cute, but it also makes it difficult to find what you're looking for by just browsing the table of contents. Okay, so here it talks about building out a model, and it shows you how JSON and Swift types align. And here you can see, here is the JSON, here is the corresponding struct, and then it introduces the Codable protocol. And then it talks about the encoding and decoding. So the decoding works by taking a JSON representation, an external representation, and then initializing your struct using a decoder. And the opposite way is to use an encoder and decode into an encoder, or encode into an encoder, sorry. Okay, and there is another concept that's really important when using Codable, and that's called the coding keys. So let's imagine that the external representation is something that you need to adhere to because it is for a piece of software that already exists. Maybe it is an API that you call, maybe it is another application that another team member wrote, or you know, anything, you know, at least you need to adhere to it. And that means that you need to somehow tell your code, all right, so we need to specify the keys that we want to use, or we need to omit some of the keys, or stuff like that. And that's what you can do using the coding keys. All right, and then it walks through the entire process of decoding and encoding, and you know, it's very, very complete. But the key point to take away from this is Codable is a protocol that you can use to turn a struct into a JSON representation and back. So, and this is what we want to do. And you might be wondering, why do we want to do this? Let's take another look at Firebase Cloud Functions Codable. Oh, look at that. There's me. We've got this Map Cloud Firestore data with Swift Codable article in the documentation that I wrote. And let's see if the documentation talks about Codable as well. It might not. So, organize functions, no, that's not what we need. Write functions, test functions, monitor functions, call functions directly from your app. Node. Deploying. And then, okay, so here's Swift. Yeah, so, And this is probably the reason why Xcode suggested this this way of calling it, because it's in the documentation. So we didn't document this well. So that's my task to do after I get off this call. Anyways, so we'll have to implement this ourselves. So before I jump into that, let's quickly see what Noe was typing. Okay. I'm wondering if it generates a key that self-verifies the token and then the key gets reset when the emulator resets. Just a guess. Maybe. Okay. All right. We'll see. Back to Codable. So instead of trying to call this function like this, we want to specify that we want to use Codable. And let's first take a look at this function here and see if there is any way how we can specify the Codable protocol. And let's see, we've got the HTTPS callable here. Callable result. Nope. But here. Okay, so here it is. Okay, so and it's even documented. So in order to call a Cloud function using Callable, we first need to specify it like this. So we'll say we want to have a callable, and then we specify the input and the output type. So here the input type will be a greeting request and the output type will be a greeting response. And then we get the function's reference, we get the HTTPS callable function, and then we specify the function that we call. Okay, so let's copy this and come back to our original call here. Insert it here. Okay, and then let's do it this way. Let semantic QA flow equals, and we want to specify a type first, so it's a callable, and we want to pass a string, and we want to get a string back. And now we can get the functions reference functions dot HTTPS callable, and now we provide the name, and I'm going to copy this to prevent any typos. Okay, so we've got our cannot find functions. Oh, yep. Functions. So we've got our yep. We've got our functions reference. Okay, so this should work. And this thing here now it behaves like a Swift function. See? So we can pass in the data, and it even tells us that data is a string. So we can pass in question and let response equals semantic QA flow, and then we can comment all of this here. And of course, we need to mark it using try, and it's asynchronous. And now we can return it, return response. So that is the first thing that we need to do. And if we try to run this now, we should get an error message, because now we're sending the data in a different structure than we did before, and our backend has not been updated yet. But let's see what's going to happen. Can I get an emulator, please? Oh, it's still compiling. And here we go. So here is my emulator. Sorry, simulator. Let's have a moment of silence for the simulator. Here we go. Okay, so in this chat bubble here, we get our chat, and now let's try to send a message, hello, and nothing happens. Okay. This is, I mean, I expected something else, but let's see what is happening. So it says something about connection refused. And I mean, like, we're just like completely swallowing this exception here. So let's try to do this in a better way. Catch, oops, and then return. Oh, and there we go, permission denied. Return error, or there was a problem. Error.localized description. Okay. Okay, so let's try signing out and signing in again. Oh. And see if this works. So test@test.com. Sign in, and then let's try this again. Hello, internal. Okay, and here is my token, by the way. Yeah. And we get this error because our backend has not been updated yet. So let's go into our backend and make the change. So we've got our semantic QA flow callable here. And this is what we're calling from our client application. So as you can see, last time we specified this input schema here. And the input schema says, here is an object, and inside the object there is a parameter called question, and that is a string. But instead of sending an object, now what we're sending is just a string. So we can just replace this and then remove those lines. And now We no longer need to unpack this here, and we can make use of this very fancy TypeScript or JavaScript feature where you can easily destructure something into this object here. And I think that should be it. Okay, so hopefully the compiler did its job in the background. Yeah, apparently. Let's see if everything's back up and running. Looking good. Let's give this a try. Hello. And here we go. Okay, so this has worked, and you can't see it. I'm so sorry. So this is working fine now, except for that hello is not very useful, but it still tries to answer the question based on the data that it was able to find in the database. And again, by looking into our trace, we can see that this is the latest trace that we ran, 828. So that is just now. And I can go in, and then I can see that I sent hello, and I can click myself through this entire call chain here to see what happened. Awesome. So that is the first thing that I wanted to do this time around. So we've cleaned up our calling code nicely, and we can remove all the comments here. So that should be fine. And just to show you what you'd need to do if you wanted to send something more complex than just a string, what we would do is struct not query fake response, QA query is of type conforms to Codable, and we could say var question is a string, and then we could send other parameters, right? So for example, var I don't know, level of detail might be an int. I don't know what we want to do with it, but we could say, yeah, we could use that information in the prompt and say be very specific or be very terse or whatever, right? So and then instead of passing a string, what we do is we take this and then pass it here, and now the compiler says, well, this is no longer compatible, so we'd have to construct our query here. Query is QA query with question, and level of detail is optional, so it won't be sent, and then we can pass it here. This is something that we might come back to once we start implementing history for our chat. So I'm going to undo this for now, but just to show you what you need to do if you want to send something more complex than just a string. Cool. So the other thing, let's update Genkit to the latest version. In order to do that, I'm going to do something which all the Node developers will probably hate me for. I'm just going to kill the Node modules folder, and I'm going to remove the package lock. And then I'm going to replace this version specifier with 1.0.0 release candidate specifier, and then replace all of the version specifiers with this new version. Okay, let's see. Did I get all of them? I should probably have used search and replace. And then npm install. So this will fetch all the latest versions of all the packages, and it should give us the latest version of Genkit as well. So just to double check, we can look into the package log once it's finished. Here we go. And then let's search for this one here. Yeah, this looks good. So release candidate 15. So it's not released yet. We're getting there. We're close. So that's the first thing. So let's see what happened. There are a couple of things that might need to be updated. So the first thing that we have here is it complains about this embedding here. And if we look at the error message, it says argument of type embedding, which is an array of number, is not assignable to a parameter of type number. So this field value vector obviously expects an array of numbers. So we're not passing this in, so something is wrong. So let's look at what's the problem. So embedding is what we get here. And yeah, this is really hard to read, but I think what it said here was more useful. Okay, so I think, okay, so this is where the problem is. So instead of, we are thinking that we're getting this part here, whereas in reality, we get this entire thing. So we need to reach into it and then get this inner embedding here. So let's try that. So we can try to use destructuring to do that, but this doesn't work. So it says property embedding does not exist on type embedding, number, metadata, so on and so forth. And this is really confusing. So when I prepared for this, I was like, what? Why? I mean, it's clearly here, right? So it's clearly on here, but there is a thing that is a little bit hidden, and I don't know if you can spot it, but see that there is an array. So we actually get an array of this object here. So, and I think one way to deal with this is to say embedding response. Yeah. Well, okay. So what it said before was correct. So this is not correct, but let's see. Yeah, this does not work. And we'll probably want to get the first embedding up. I'm not entirely sure if we just need to get the first embedding, but at least compiler's happy now. We might want to log this, so console.log, and log the entire embedding so we get an idea of what it returns. All right, so that's the first thing. And it seems that it's still compiling, which is good. But there are a couple of things that might make our life easier. And the first thing that I wanted to show you is the way how you reference a model changes. So we've got Gemini 1.5 Flash, which we refer to in 2 locations. Let's go here first. So instead of referring directly to a model with a constant, what you can do now is slightly different, and it's pretty difficult to see here. So let me show you here. So instead of referring to a model directly, what you do is you import this model function, and then inside of here, you can refer to all the models that this plugin provides. So let's use 1.5 Flash as we did before, and that is the first change. And we also need to update this down here, Gemini 1.flash, and update it to this. And now we can remove this. And that's referring to models. And then the other thing is, if you look at, and let me make this bigger. If you look at the way how we expose this this flow to the outside world, it's a little bit hard to see, but what I did last time, I made a copy. So here's our semantic QA flow. That is the internal flow. And in order to expose it, I made a copy last time and then wrapped it into this onFlow call. So that has changed. Instead, I'm going to delete this now. And then I can say export con semantic flow callable, and not use onCall, but onCall Genkit. And we probably need to import this. So we can get an import, and then I can use the name of this flow here to call it. And that's it. But so this exposes the flow as a callable, and this is obviously a lot easier, a lot cleaner to read, also a lot easier to write, because you literally just wrap this. But there are a bunch of things that you should do in order to make this more secure. And you can see that there are callable options that you can pass. And those callable options, let's expand this, have a couple of attributes. For example, enforce app check, which you can set to true in order to enforce that only applications that are genuine apps can actually call this callable function. Or you can say, I want to provide an auth policy. And that means your flows can only be called by a person who's signed in to your app. So all of these things are really useful to make sure that your application can only be used by legitimate users. So let's start and say we want to use an auth policy. And there is an auth policy called sign in. Yes, please import. And we can remove all of these and go back. Okay, so the is signed in authorization policy requires a user to be signed in. So it probably verifies that the user is signed in by looking at the authentication token. Let me see, did I want to enable something else? Oh yeah, and then another thing that's pretty useful, you can provide a secrets parameter. And this is super useful if you're using any LLMs that require you to pass an API key. So instead of somehow baking your API key into your code, you can use Cloud Secret Manager. Or, well, this mechanism here really is just here to pass the secret to the call. But in addition to using this, what you can do is you can use Cloud Secret Manager. So let me see if I can remember this correctly. Let's do this here. Consts. Yeah, so this is how you would typically do this, but instead we'll do define secret, and yes, please import this. And then pass it over like that. And the cool thing is, if you use define secret like this, it will automatically provision the secret for you when you first deploy. So that means if you run Firebase deploy and the Firebase CLI realizes, oh, there is no such secret called Google Gen AI API key in the Firebase project that I'm deploying to, it will ask you, can you please provide the secret here? You can type it in, it's hidden, so you can't see it, even if the screen is recorded. And then it would store the secret in your Firebase project. And then when you run your flows and your application starts up in the background, it will automatically fetch the secret from Cloud Secret Manager. And the really nice thing is that everyone who has access to your Firebase project can go to your Firebase project and change the secret, except for people who don't have access to your backend project can't do it. So this is really nice because your developers can work with secrets that they define in their local development projects. And once you go to production, the person who's responsible for running your production backend can define a production secret that is completely separate of any other secrets that might have been used in development. So that's really nice. Cool. So I think that was mostly what we wanted to do here. Let me double check. Yep. Okay. So let's go back into our emulator. Still running. Genkit is still running. And we should be able also, okay, so we might have to restart because I think, yeah, so this still says 0.9.12 and we want to get the latest version. So I assume that we will have to kill the emulator and then just restart it. And that will hopefully give us the latest version of Genkit UI. Yep, there we are. Okay, so here you can see 1.0 release candidate 15. And when we go to the home page, you can see that it's now really nice and clean. You can see this dashboard with your models, with your flows, with all the embedders, with the retrievers. And you can also see the trace history. So I'm going to make this a little bit wider so you can see it. And the nice thing is that you can even see the input and output parameters. So you can see that I sent hello. Let's try to invoke this from our app. And now let's ask about what do I need to do in order to create custom SF symbols, send this. Here is our answer. Let's go here and refresh this. And here is our latest trace. What do I need to do in order to? And you can even see the response. We can click on this and then we can inspect this and drill into the entire flow. I think the icons have also been refreshed, so really nice work here. I think this looks really amazing. It's really great. And you can see all the details of the call. Perfect. So that was mostly what I wanted to cover today. There is one more thing that we can take a look at that I saw today, which I found interesting. So Keith wrote an article in the newsletter. Oh, interesting. Why is it not? That is really interesting. Is it not on the site? Let me look into my emails, but off screen. Because Keith wrote an article which was really nice and it talked about development assets. So use your loaf. Okay, so I need to go into a different inbox, apparently. Use your loaf. Yep, here we go. Read on the web. Okay. So, oh, and now, now I understand. Interesting. So, so it's not new, but apparently pretty old, but it's pretty useful stuff either way. So what Keith walks through here is how and where do you store your SwiftUI preview data. So what most people do is you go into your preview provider, and this looks different today because Apple has made this easier to rate the preview provider, but people would generally set up their demo data that they want to pass into a view like that. And if you have lots of views that show related data, then you will start duplicating the data. And in this example, it's even worse because it's slightly related data. So you need to make sure that everything is, corresponds to what you do in all the other places. So that is a lot of overhead and a lot of maintenance burden. And there is a thing called development assets. And you might have seen this if you go into Xcode. So let's try this out and see if this works for our case. So if you go into Xcode, oh, look at that, it's no longer here. Or is it somewhere else? So I used to recall that there is a development asset thing here. So maybe it's no longer here. Interesting. Okay, so let's see. maybe they got rid of it. Development assets Xcode 16. Okay, so here's another article. Oh, preview content. So let's see if that is there. Oh, oh, there it is. Okay, here we go. So, and let's see if we can move our code into there. So where is, let's use this article. So and that's what we do as well, right? So we've got an extension on our model. So we've got artifact plus mock. So that is an extension on artifact. And we have this over here. So, so we've got this preview content. And now let's see. So he actually moves those files over. So let's try this as well. So let's move this one and move this here. And let's see if it still compiles. Yeah, looking good. Okay, so that means that this mockable extension and everything that's in here should no longer be part of our release build, and maybe not even of the debug build. So in order to verify if that is actually the case, what I'm going to do is I'm going to try to get the artifact.mock down here. Let this should not work equals artifact.mock, and then let's try to run. And I would expect the compiler to complain about this already. Well, oh, it seems to work. Let's see if we can switch to a non-debug configuration. Release. And run this. This is interesting. So well, still building. Okay, so maybe it'll start complaining any minute. Oh yeah, because now it's a release build, so it has to recompile everything from scratch. And with the release build configuration, so that's a lot more work. I'm just curious why it doesn't build succeeded. And it's still working. Print this should not work dot title. Yeah, so it does work, which I found pretty surprising. So this kind of defeats the point, right? Because here it says Xcode treats this asset catalog differently from your app main asset catalog. Will not include any assets you add to the preview into your release builds. Okay, so maybe. Okay, so that's that code stripping to the rescue. Xcode's dead code stripper makes sure code references in previews won't be included in the final app binary. As long as you're using the sample code in previews only, it can be a great way to define sample data in dedicated place inside your project. To be clear, we're not adding these Swift files as development assets as we did before with our preview asset catalog. The reason would fail during archiving. Okay, let's try that. So let's try archiving the code, product, archive, and see if this fails. Okay, maybe we can look at the build process here. So where are we at? Okay, it's building the target. So we should be done any moment now. Compiling, so this is compiling the main application now. And here we go. Okay, type artifact has no member mock. All right, so apparently this does work. So now, yeah, but, well, you know, I would have, are we done or are we not done? So I'm really surprised that it complains about this here, because I would have expected it to strip this out. So we've got a problem in this view builder over here, which is here, and then there's a problem here. Yeah, so coming back to what Antoine writes, you could solve this by using if debug checks, but that's not always nice to use. Yeah. So I'm guessing if we went in and said, okay, let's if debug, is that the correct syntax? If debug, and then end if. So this should solve the problem. But to be honest, I wouldn't want to do that, right? So let's go to all the other places. And then go here. That's what we did already. end of. And here is another one. Yeah, okay, so this one I kind of was expecting. The other ones not so much. So let's archive one more time. Okay. Let's take a look. Yeah, I wonder if this works as intended or if this is a bug. Or maybe I'm misunderstanding the whole thing. Okay, still building. Now we're compiling the main app. Okay, and yeah, so in the main app, we're trying to access the mock and mock lists in 2 locations, which is, yeah, this is what I expected. It's just, a little bit surprising why the preview macro doesn't automatically include debug handling. Maybe we can expand macro. Hello? Here we go. Yeah, so there is no ifdev debug. All of the ifdevs are the ones that we added ourselves. All right, so I don't know. Maybe it's a bug. Maybe we're supposed to add ifdevs. Who knows? If you've got any opinion about this, let me know either in the chat or on the recording in the comments. And with that, we're at the end of today's stream. I hope you learned something. And let's see, what can we do next time? So we're pretty close to some version of MVP-ness of this application here. So I'm going to think about what we're going to do next. Oh yeah, I know. We need to handle the history. So that's definitely something that we still need to do, and we probably need to refine the authorization story. That was something that I stopped working on once we had it working somewhat the last time, or a couple of episodes before. So that's definitely something that we should start revisiting. Oh, and also chunking, because at the moment we're trying to embed entire documents, which can be pretty massive and not such a good idea, and also pretty costly. So that is definitely also something we need to get into next time. All right, and with that, thanks for tuning in. It was lovely to virtually see all of you. I hope you have a great rest of the day wherever you are on the planet. Stay safe, and I will see you again next time. Bye all.